tomorrow, okay? So tomorrow is brand new, okay, for you. This should be review from Algebra 1, but you haven't done a ton of it in geometry. So I just want, be aware of that. But tomorrow is kind of tricky, so bring your A game because we're doing fractional exponents, okay? So that's where it can get kind of fun, okay? So here's the gist with exponents, okay? You can memorize the rules, that's fine. I don't technically really have a lot of stuff memorized for math because there's already too much to be put in my brain for this. So when you're multiplying two exponent rules or two exponents with the same base, you add the powers, okay? So for this one, like x cubed, think in your head you have 3 x's multiplied together, and then x to the 5th, think of having 5 x's multiplied together, okay? So what ends up happening is now you have 8 total, okay? Wow. Same with the quotient when you're dividing them. I think of how many are going to be left on the numerator versus denominator. So technically you subtract the powers. That's what you're supposed to do. But really what I figure out is how many y's are on the numerator, how many y's are on the denominator, and then kind of the same reasoning as the integers, how many are going to be divided out. So those big slashes aren't slashes, they're ones. They're just big slanty ones, okay? So what I'm going to be left with is 4 y's on the numerator. So I don't think of the subtraction necessarily. I just think about how many are left on each side. If you're raising it to a power, you're doing groups of x's, so it's easier than writing it out. So x cubes, if you're squaring it, you're taking 2 x cubes times each other. Okay, so 2x cubes times each other, which gives you 6 of them total. And then if you've got a lot going on in a parenthesis, it's still the same thing. You're doing groups. So you're doing groups of 4. So that's why there are 4 parentheses here. And you're multiplying them all together. This one, I kind of tend to do the rules. Okay, I'll distribute that 4. So whenever there's no power, it's just an invisible 1. So as long as you remember that's an invisible 1, it's you're doing 4 times 1, 4 times 1. For both of them. Quotient, you do the numerator and denominator. It's the same deal. So this guy, you're doing 3 times, which is the cubing part. So that's why there's 3 of them, because you're doing cubed. And then 0 exponent, this is 1. I'll show you why down here. But the 0 exponent is always 1, no matter what the base is. Negative exponents mean repeated division. So if you have a negative exponent, it means you're just dividing by it. Think of it as maybe I'll do 2, because that's maybe easier. 2 to the negative 2, or let's do 2 to negative 1. That's the same thing as 1/2. Think of it as divide. The way the negative works, it means divide by 2 once. So if it was a 2, you divide by 4 twice. That's the way you think about it. So that one, if you have a negative on the denominator, you move it to the numerator, and if it's on the numerator, denominator. So here's the reasoning. So for exponents, if you notice here, you probably know from here to here, you see how you're just multiplying by 2 each time? Or maybe I should look down here. So 2 to 4, you're times 2, 4 times to 8 is times 2. The positive exponents would mean repeated multiplication. So if you were to go backwards, so if you think of it backwards, so if you're starting at 8 and going to 4, come on, it would be divide by 2. Same thing, divide by 2. That's where it's 1 all the time. You're dividing by 2 each time. So 8, 4, divide 2 by 2 is 1, divide by 1 by 2, you get a half. So going the opposite way is division each time. Okay, so divide by 2 or multiply by half is another way to think about it. So positive exponent is repeated. So if you're going like that way, doing positive numbers, that's repeated multiplication. And then the other way is repeated division. So when you see a positive exponent, think multiplying. When you see a negative exponent, think dividing. Because that's what they mean. So, all right. So now we're just going after it with examples. Some, they start off kind of easy, but then get harder as you go. But for this one, I put this one on here. Maybe I don't need this type, but I just want to make sure that like you know that that's an exponent of 1. Okay, so 3 cubed times 3 to the first. Stop talking, please. There's 2 ways in your brain to think about this. If you did the rule, it would be 3 to the 4th. Okay, you add the exponents. But how do you know that? Think about it this way. If you did 3 cubed, that's taking 3 3s and then times 1 more. So there's 4. Okay. Now the even powers are actually pretty easy, believe it or not, to do in your head. Okay. You might think like 4th power, that's insane. But the way you can think about that is if you take 3 squared, like take one of these guys. This is like a little math trick. This is the same thing as 9 squared. So what I do for 4th powers is I square it, 9, and then square it again, 81. Okay, so when I do even powers, I just keep squaring. So I'll square 3 to get 9, square 9 to get 81. On your calculator, it's that little like caret button. You would press this thing and then the 4. So you would do that on your calculator. But you can technically do it in your head, okay? All right, some of these other ones, like here, what I do is just organize everything. So like I'll take, there's like an invisible 1 in front of the x, so I'd go like 2 times 6, and then I'll take any variables, and then I'll do like x cubed, x to the 4th, and x. And then I'll multiply the actual numbers, so 12. And then I, technically in my brain, I'm counting up the x's. So I've got 3 x's, another 4, and then 1 more. Okay, so that'd be, what happened? There we go. X to the 8th. There we go. Why is this so fat? Oh, that's why. So it would be x to the 8th. Again, what I'm thinking of is 3 x's, another 4 gives me 7, and then 1 more is 8. Okay. All right, then 3. Now, the way you think about this one, okay, is you need to think of it 2x squared, 2x squared, 2x squared, 2. That's really skinny. Sorry, you can't even see that. 2, there we go. 2x squared, 2x squared, 2x squared. This is kind of annoying, but that's okay. 2x squared. Okay, 5 times. That's what you're doing. So the power rule, you could do the cheat way where you could just do the power rule. So that would be, oh my gosh.
Wow.
It sometimes randomly does that, so that's fun. It does. All right, so this is essentially what you're doing. Okay. So you would raise 2 to the 5th. And then with the x's, you have x squared. Oops, I wanted that in red. So it would be x squared that was in there. But then what I'm going to do, because if you think about it, you have 2, 2, 2, 2, 2. You have 10 of them. So the rule is you multiply the exponent. Okay, so what that ends up happening being, so again, I'll do to the 4th power, 2 squared is 4, squared again is 16, and then you need another 2. So that's like how mentally I'll do it, but you'll get a calculator if that makes you feel better. But it'd be x to the 10th. Okay. So it's 32 because 2 to the 5th. So 2 times 2 times 2 times 2 times 2. Okay. No, because you have to times the 2's together.
Oh, I see it now.
Okay. So it'd be, all this is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32.
Oh, okay.
Yeah.
It's basically multiples of 4.
Kinda. It's multiples of 2.
So where exactly will we need to use this?
So
When you're counting your cheeseburgers at McDonald's.
don't worry. And then x to the 10th. Okay, now this one, think of it this way. 5 sets of these. So think of how many x's if I wrote that over 5 times. Okay? So there'll be 5 of them. Okay? And then think of if I wrote y squared 5 times. Okay? So this is like, think of it this way. Maybe that's better.
This is gonna be whoa. Whoa.
Okay? So, guys, stop the conversations, please. So there's 1, 2, 3, 4, 5 x's. That's where x to the 5th comes from.
Oh, I see.
And then there's 2, 4, 6, 8, 10 y's. Okay?
11.
No. Yeah, you just multiply the exponents. But everyone messes up whether you add them or multiply them, so I always picture that in my head. It's annoying to write out. I don't blame you for that, for sure. But this is what happens in my head. I think 5 x's, and 5 groups of 2 y's. So 10. Okay.
So just do x times 5.
Yeah, you're just multiplying them.
Why don't we just do that?
Okay? Because people forget it.
Some people will learn visually, Mark.
Yeah. So 2/5 times itself 4 times. That's what I'm thinking of. Okay. So 2/5 times itself, you're going 2 times 2 times 2 times 2. Or if you did the rules, it'd be 2 to the 4th over 5 to the 4th.
5 times 5.
And then you would have to do like all that multiplying, okay? So for 2 times 2 times 2, 2 to the 4th, I'll go 4 times 4, 16. Or you could just keep multiplying them. Again, you'll get a calculator, so you could just type in 2 to the 4th. 5 to the 4th would be 25 squared, so 625 would be how it is. Or you could type it in your calculator. You could just type it in. It's fine. Okay?
Won't you also just do 25 squared?
Yeah, 25 squared. Yep, exactly. That's what I did in my head. Yeah, exactly. All right, now for the fraction ones. Okay, so the rule is you subtract, okay? But what you should be picturing is picture your 9 x's. Is that 9? No, 8. And then 4 on the bottom. So, like, you don't have to write that out. It takes a while, obviously. But think of this happening in your head. So think of, I've got 9 on the numerator, 4 on the bottom. 4 is going to take out 4 from the numerator. So it'd be x to the 5th. Yep. Okay, so that's what you're doing in your head. Okay. All right, same thing here. You have to think, our x is going to end up on the numerator or denominator once you start canceling, right? So it'll be, you have 5 on the numerator, 7 on the denominator. Right.
X squared.
So it wouldn't be x squared. That's the best wrong answer. Because these slashes are ones. So you have 1, 1, 1, 1. Okay, 1, right? 1 over x squared would be what that one was. Okay. So think of dividing them out. That's what I do in my head to like organize.
On the denominator, you have 1 over the x and exponent.
Mm-hmm.
Yes.
Yep, exactly.
That's how numbers work.
Yep. Guys, come on. Stop
This is
it.
why I'm in this match.
Okay, so negative exponents.
Guys,
Okay,
everybody's at a different level.
that means exactly. The negative means repeated division. So this is what you have to do. Okay, you get 2. You have y there, but to get rid of the negative exponent, okay, whoops, you would put this. Oh my gosh.
Wait, this is done. I think this is. I say you just freeze the board. This is our.
Well, then it doesn't.
This is our sign. Whoa. What happened?
There we go. You would change it to a positive by putting the denominator. So if you have a negative exponent, you're going to throw it in the denominator. And there's nothing to cancel out on here. That's it. So for exponent rules, if there's multiple x's and y's, you need to divide those out or multiply them. If there's negative exponents, you got to clear them. So you got to put them on the denominator.
Is it always on the denominator?
No, if it's on the denominator, you move it to the numerator.
That's the exponent.
Yep, exactly. Okay, so notice that -3 is not on the 7. Okay, that thing is on this x right here. So what I'm going to do, well, I guess I could keep the 1. It doesn't hurt anything. Okay, so the 1 and the 7 stay, but because I have a negative exponent, I'm going to move that to the numerator. So if the negative's in the denominator, you're moving it to the numerator. And if it's in the numerator, you're going to move it to the denominator. And it comes from the idea that it's dividing. Hey, Brandon, can you close that, please? Then where are your notes? Well, take them out, please. Okay. All right, now we're getting crazy. Ready?
This is like way too hard.
So here we go. So just like PEMDAS, I'm going to mess with the inside first. The only thing I need to mess with is the w, because that has a negative exponent. So everything is going to stay. So the 2x squared y cubed z is all going to stay on the numerator, but then the w is going to be on the denominator. Okay. Now it's going to be a little sass again because we've got this guy. So if you have a negative outside of a fraction, okay, what you're going to do to make it positive, okay, so what you're going to do is you're going to reciprocal. Yeah, you're going to flip. Okay. So it's a lot of rules. And it's the idea of division. So changing division to multiplication, you know how you multiply by the reciprocal with fractions? Think of it that way. So negative exponents mean division. So undoing them means you need to divide. Okay, so when you divide fractions, you would do the reciprocal. Now, you could think of that whole business being multiplied 4 times. So it's like kind of psychotic. So maybe you don't need to write this down because it would take forever, but it would be this 4 times. You know, do blah, 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 okay? 4 times, okay? So think of how many W's you'll accumulate if you do it 4 times, okay? So if you had 4 sets of 5, no, because you're going to have 5, 5, 5, 5, 20. 20 of them. Yeah. So you're going to have 20 of them. And think of how many 2's you'll have. Okay? So 2, 4 times, 2 times 2 times 2 times 2, 16. Okay? Shh. X, your squares of them. So 2, 2, 2, and 2. So that's going to be 8. Okay. How many 3's? 3 sets of 3. Or 4 sets of 3, sorry. So you have a cube, a cube, a cube, and a cube. 12. Yep. And then you have 4 sets of 1z. So a z, a z, a z, and a z, so 4. That's your answer. So that one's like pretty intense.
So, like, is that for the...
No, we got 2 more that are even harder.
You got 2 more.
more.
So why don't we try this one?
No.
Try it. It's really similar to the last one. See if you can get it.
Flip it.
Yep. You're going to flip it. Nope. Try this one. You'll be okay.
What if I just died now? You said no.
I'd be very sad. So you just flip them right away.
Mm-hmm. Yeah, I know. You're working on it. You're by yourself. See if you can get it.
I missed that.
Yeah, Mark, she isn't going to give you the answer on the test, is she? Hopefully. Smart.
That's true. 3 to the 5th.
Hey, Scoop, you found your pen? I did. Where was it? In my backpack.
Okay, do the problem. Do the problem. Number 10.
So you flip it.
You're writing this stuff down.
Let's go.
Yeah, because I don't feel good.
Or number 11.
Jackson, you flip it.
What do I do?
Alright.
Flip it.
Yeah.
And then I
Well, you didn't do 3 yet.
That's it. Dude, you just got me.
That's it.
That's so sexy.
Yeah. Nice.
That's just a different way to do this.
6, 7.
You had it the first
Am I
time.
doing it right?
Did you buy anything at the gas station?
Am I doing it
Nice.
right?
You just gotta flip
Yeah, that's
it.
right.
So instead of doing all this, all the.
Yeah, you guys do. Oh, this is close. It's not 3 times 5. It's 3 to the 5th power. So it's like 3 times 3 times 3 times 3 times 3. So it's pretty big. You might need your calculator for that one.
When are we going to use this thing?
So don't worry, we'll have more problem day. Is that what you want?
No, I want.
All right. All right.
I don't feel good.
Okay. All right. So first thing you do is flip the fraction to deal with the negative. Okay.
I did that.
Now what happens? The rule is you multiply them all. Okay, the powers. Or think of 5 sets of 3 x's. So 15, 5 sets of 2 w's, 10. 3 to the 5th power is 243. Okay. A to the 10th, B to the 5th. Okay.
We keep that up there.
I was going to get there.
Okay, so repeated multiplication. No, you gotta do it all. Yeah. That's how ACT likes it, so.
I have to do this on the ACT.
Yeah.
What is it?
Yeah.
Wait, do you need a good ACT score to work in McDonald's?
Nice. All right.
Ask Patty.
Okay. For this one, okay, W to the 0 power equals what? 1. Okay. So what you can do is just put a little 1 there. Okay. Now we're doing the numerator and denominator separately. So think of it, again, you don't need to be writing this all the time. I just think it's,
Flip the 6, 7.
this is what you're doing. 3 times. 3 times the numerator. Okay, that's where this is coming from. And then we have 4 on the denominator.
I do not want any of those Cheerios, bro.
Okay. Nope. Okay. So we have groups, 4 groups of these. So you have to figure out how many x's are on the numerator. 6 of them. And then how many y's are on the numerator? So 21. Okay. Then we have x cubed. Write this down. Write this down.
If I write it down,
Okay. Then here we have 1, 2, 3, 4 groups of 3 x's. So x to the 12th. And then y 5, 5, 5, and 5, 20. Okay. Now what we're going to do is we have x's on the numerator and denominator. Okay. So if you compare the x's, we compare the x's, okay, the denominator has more. Okay, boys, there's a denominator has more. How much more? 6. Okay, now with the y's, it's a close game, but we've got 21 on the numerator, 20 on the denominator.
41.
So all the denominators are going to cancel. So you're left with 1y on the numerator. You can put the 1 on there, but they usually don't write that because it looks kind of goofy.
Or anything.
Okay.
Any marker wrong.